And now for a little bit of magic. One ordinary finger and one rather extraordinary TV screen. Wherever my finger goes, up pop little stars. There you are. QPR, best team in the land. Now, the glass is perfectly normal, so how does it do it? Well, if you look closely, you should be able to see a row of what look like little glass beads running along the edge of the screen. In fact, they're photodiodes, and they're transmitting individual beams of infrared to a row of receivers or photoreceptors over the other side. Exactly the same thing is happening in the vertical plane, so what you've got just in front of the screen is an invisible grid of infrared. And when I touch the screen, I'm interrupting both a horizontal and a vertical beam, giving the machine a precise coordinate of my little finger. And with a little programming, I can use the machine to make choices. I can now select items from that menu by touching them. So let's try tic-tac-toe. That's American for noughts and crosses, so no prizes for guessing where the software came from. Now, this is just an example. In fact, this machine is not a toy. Its proper purpose, it's designed to allow people easy access to a computer without having to use a keyboard. And in fact, it can even allow you to control machinery. Look at this setup over here, a bit odd-looking perhaps, but what it does, we hope, will be fairly dramatic. A video camera and an air pistol, both pointing at a row of balloons against that wall. Now, the picture from that camera is being fed to this monitor, and from now on, that air pistol is under the direct control of my fingertip, and I can move the gun up or down, left or right. So let's go for that balloon there. And now all I have to do is to touch the screen once more, and that gun will fire a pellet at that balloon. Ah, it is nice when it works. This computer is programmed to read the London phone book. From more than 1 million entries in the directory, it will scan 100 pages a second and, in a matter of seconds, reveal the names and addresses of everyone on the phone in any one street. Pretty useful information, that, for many people, from salesmen to burglars, thanks to the speed and power of today's computers and the way in which they use information about us, and not always for the purpose it was originally meant. OK, that was just one example, but it's this traffic in personal information, often international, that's led to increasing pressure for some sort of supervision. Hence the government's proposition to set up a data registry, which will require users of computer data banks to reveal what they're doing with that information. It's also supposed to give us the right to know what people are saying about us, which for the most part we don't yet have. But will it? Because a great deal of the information that's whizzing around the world is in such a complex code that it's virtually uncrackable. For instance, say I want to tell a colleague in Los Angeles what I had for breakfast. OK, sausages. Now, first the computer jumbles the letters up to disguise the fact that it's an English word at all, and then it turns each letter into 8 digits of computer code, and that's 64 in all. And then it takes each block of 64 digits and changes them round again using a complicated code called an algorithm. And this second set of 64 digits is now so well disguised that only I and the person I want to get the message to can understand it, because only he and I hold the key. And if you tried to crack the code without the key, you'd find yourself staring at 2 to the power of 56 possibilities. And that, I'm here to tell you, is 72,857 billion. An awful lot of possibilities, and each one as likely as any other. So, many people are deeply suspicious that all the government's really done is to come up with a token gesture that's just sufficient to allow us to comply with European regulations, which UK firms must do if they want access to European data banks. Now, you might think there must be a computer somewhere to crack that sausage code quickly. You'd be wrong. Even the biggest mainframe computers around today would take more than 1 million years to come up with the answer.
This is BBC One, and this is how we create a picture of our symbol. But if during the new year we happen to want to change our symbol, then of course we'd have to build a new model, like this stupid square world. But there's now a better way of trying out new designs. Instead of having to build a solid model like that, this system does away with Christopher Columbus and goes for a flat world. At the moment, this ordinary piece of artwork is being looked at by a television camera. But the magic comes when the picture from that camera is fed into this device with its control box. So, instantly, I can get a round world, or if I happen to want to, I could have a cylindrical world, or better still, a randomly turning square world. So with this device, you can instantly try out different ideas. It'll be used in television programs and adverts where the artist wants three-dimensional, solid-looking images. To date, the only alternative to making a model has been film animation. But these Newsnight titles, for example, took 2 weeks to draw and film, even though a computer was used to work out the movement. And the reason that the animation takes so long is that hundreds of separate pictures like this have to be drawn and photographed one by one to make even that short-moving sequence. So how can my little box do all that sort of thing instantly? Well, it's based on the same electronics that have been doing this for some time. You've seen it in everything from Top of the Pops to, well, Tomorrow's World. What's happening is that the 625 lines that make up the television picture of me are being rearranged. For example, normally line 1 at the top is shown first, then line 2, 3, and so on, right down to line 625, which is along the bottom. But if we reassemble the picture with this bottom line here first, then it appears at the top and I become a star of Australian television. By constantly recording the lines and replaying them at the wrong times, all these effects can be achieved. But you'll notice that the picture never wraps round on itself. It's always some variation of the simple two-dimensional flat image. To take the leap into 3 dimensions, this unit has divided every line of this picture into 1,000 points. And that means for the whole picture, 625,000 points are memorized at any one instant. And the beauty is, any point can then be repositioned anywhere on the screen at any time. And just to prove that it's made up of thousands of separate points in the memory, I will now disintegrate the world. Oh, the power of it. And it doesn't stop at using still pictures. Let's try some tricks with this train set. How about a paper chain train? Or I'm told that this is called a Möbius strip. And here's something that Walt Disney has spent years developing, the page turn effect. And if you happen to want to have a different picture on page 2, that's no problem either. Well, I thought for my finale, as it's still the festive season, that I'd invite you to have a drink on me. Here's the artwork. OK, I'll just wrap it round. No artificial flavouring in this drink. Just a free train set in every can. Not bad. I'll just round off those corners. Yes, I can hear it now.
Future Fizz. It's the real tomorrow. Canned as only McCann can.
For years on Tomorrow's World, we've been heralding the arrival of the non-polluting electric car. Well, here they've actually made it a certainty by act of law. And we're not talking about just the odd token vehicle here. The law states that by 1998, 2% of all cars for sale have to be zero-emission vehicles. And that figure rises to 10% in 10 years' time. That legislation has made Los Angeles the place to come if you're into electric vehicles. Here, promotional hype and technology go hand in hand. For example, the local electricity supplier has installed a roof full of solar panels, forming a sort of solar carport. Even in sunny California, it can only charge a couple of cars a day, but people are starting to plug into the message.
We get about 30 calls a day asking, where can I get an electric vehicle? What's happening? When will they be on the market? The media does lots of stories. The auto companies put out information.
What about the running costs? Will they be comparable to ordinary cars?
The electricity will be a lot cheaper than gasoline would be. Maybe if you average paid $20 a week for gasoline today, it'll be $20 a month for electricity. And the maintenance will be a lot less because an electric vehicle is so much simpler to operate. But the real question is, how often will you have to replace batteries and how much will they cost?
Out here on the west coast, it's not just running the vehicles that concerns them. The Californians are also determined to profit by the move to electricity. They mean to pioneer the manufacture of the vehicles in an effort to restore some of the skilled jobs lost to the shrinking aerospace industry. Take this place, for example. It used to hum to the sound of machines making parts for airplanes. Today, it's been taken over by a consortium to find the best answers to technical questions. For example, where do you put those batteries? Answer, under the dash. Tyres with low rolling resistance, could they save energy? And to improve the car's 60-mile range, could it feed current back into the battery as it slows down? Recharging has to be convenient and done easily at home, say overnight. And quick recharging has to be possible at the recharge stations. And another way to deliver the electricity to the car is to use one of these, a new loop charger. No electrical connections here, just magnetic induction, so it's perfectly safe to use, even in the rain. And here's another little challenge. The heater in an ordinary car gets its heat from a warm engine, but with no warm engine, where do you get the heat? An electric fire or fan would drain the battery in minutes, not to mention the air conditioning. So here's an alternative. It uses something called the Peltier effect. The junction between two different metals in here freezes when you pass a current through it in one direction. There, it's frozen solid in a few seconds. And then heats up rapidly when the current is passed through it in the other direction. And now you can see it's starting to boil away. With a number of those junctions embedded into the car seat, you can have highly efficient heating, or more applicable to this climate, cooling.
So Trevor wondered whether it might be possible to make a portable radio that didn't need batteries at all.
Before the show was over, I was into my studio and I managed to get a bark of sound out of an instrument, and that was my, if you like, my eureka moment.
And that eureka moment produced this, the world's first clockwork radio.
All I've done is added a very good bit of old tech, the clock, with a very good bit of new tech, which is the radio. And I've just combined them together.
So what's inside all that?
Well, what you've got is a box which contains a fairly powerful spring. This particular spring then drives through a gearbox and some electronics, a generator, which in turn propels the radio. And now all you have to do is to wind the radio up.
Just like a clock.
That's right, and now it will run without batteries.
And with the help of a tree, Trevor's produced an even more inventive radio.
Well, what we've done, in fact, is put the generator onto the tree.
So it's the same thing, same mechanism.
Exactly the same, except this time we use gravity to propel the radio, right? See, the string goes up and over the pulley here, and then down here onto the bucket. So all I do now is simply wind the handle, and you'll see this bucket come off the ground. I've just put some soil or water into the bucket, and now you'll see it slowly goes down.
How long will that last?
Well, it depends on how high the tree is. If you have a very tall tree, this radio would probably run for about 2 hours.
Although Trevor's invention clearly works, he's found it impossible to interest any company in his radio.
Starting from the top here, I think this is one of the biggest disappointments I had. This is the Design Council. You know, the feeling of rejection when a committee says that what you've done is no good. It hurts, you know. They don't even get, you know, one would think the Design Council would say, well done, Trevor, I think it's a great idea, we'll try and help you.
Yeah. Trevor's written to every electronics company he can think of, and every one has turned him down.
They're inclined to think that there's another Wally that's just come out of the woodwork and that he's really not worth speaking to or talking to.
Frustrated at the negative responses to his radio, today Trevor and I are off to the BBC World Service. We're meeting Mick Delap of the African section to see if he believes Trevor's radio has a future in the third world.
We've got radio listeners around the world. There are, 125, 130 million people listening to the BBC. And for many of them, they listen to the radio in a way that we just don't appreciate. It's a lifeline for them. And they are desperate for batteries. We've had stories of people in Somali refugee camps, for instance, saving up their rice rations and bartering it for batteries.
So you think there really is a market for
I think there's a tremendous market if it can be, if it can work. Trevor's persuaded us that it does, but also, obviously, if it's marketed at an affordable price.
So what do you think about Trevor's position having it rejected by all the big companies?
I think they are blind to an opportunity. We think it's a great idea, we know how our listeners react, and we think they'd react very favourably to this.
Well, at last I've found somebody who believes in what I'm up to. At least the BBC believe I'm on to some sort of a winner.
But of course, Trevor still has to find the money to manufacture his radio. The BBC can't provide that.